Hello and welcome to tribetopper.com.
And you're watching this video on important concepts of electrostatics for grade 12. And in this video we are going to discuss about the torque acting on an electric dipole when it is placed in an external electric field. See, an electric dipole, when it is placed in an external electric field, acquires a rotating effect. That's interesting. This rotating effect is actually termed as the torque. See now why this happens. Now I have the charges minus Q and plus Q. We know that when a charge is placed in an external electric field, it experiences a force equal to Q times E, because electric field strength is the force acting per unit charge. Then what will be the force? It will be Q times the electric field strength. Now here, though my F is Q times E, but this force will also act on the other charges, on both the charges of this dipole. So in case of this dipole, one force is acting here, that's QE, and the other force is acting on this negative charge, that's minus QE. Therefore, my forces acting on the dipole would be both the forces, right, and with the equal magnitude but in opposite directions. So F is equal to plus minus QE is acting here on this dipole. Now since one pushes it towards the right, pulls it towards the right, the other pulls it towards the left, and as a result, it's obvious these two forces are anti-parallel, and so they are going to produce a rotating effect, because you pull it here and you pull it here, the effect is the rotation. Therefore, this electric dipole experiences a torque, and that gives rise to the rotation. So this dipole will start rotating in this electric field. Now let's find out how much torque is acting. To find out the torque acting on the dipole, we first need to find out what is the distance between the line of action of these two forces. Though they are anti-parallel, but there is some perpendicular distance here, this one. So we need to find this distance. So let's mark the points. So this is A, this is B, and this is C. So in this triangle ABC, what do we have? We have to find out the distance BC. Now BC would be equal to, see, this BC is equal to BC upon AB. It's a right angle triangle, so first we can write that step. BC upon AB is what? Sine theta. So therefore what would be BC? Obviously that gives me BC is equal to AB sine theta, and AB is the length of the dipole, which is 2A here. So 2A sine theta, that's BC. Now we know the formula for the torque. Torque is always equal to the force acting times the distance, the perpendicular distance between the two forces. That's the line of action of this. So we want this distance BC. That's F times BC. Now F is Q times E into distance R BC is 2A sine theta. So we get torque is equal to QE 2A sine theta. Now we can just rearrange the terms, because Q into 2A, that gives me the dipole moment P into E into sine of theta, and this gives me kind of a result of a cross product. Therefore I would say the torque acting on a dipole is equal to P cross E, right? So it's the dipole moment and its cross product with the electric field. That's the torque acting on the dipole. Quite simple to find out, just from the formula force times the perpendicular distance, and that gives me F times BC, which is 2A sine theta. Substituting the value of F and BC, I get QE 2A sine theta. Q into 2A, this product is dipole moment P into E into sine theta. Now this is a cross product, so tau is equal to P cross E. This is the torque acting on an electric dipole when it is placed in an electric field, and hence it starts rotating. Now since the torque acting on a dipole is equal to P E sine theta, therefore the maximum value of torque depends on the angle at which this dipole is aligned with the field. So if I put my theta 90, that means my dipole is placed perpendicular to the field, so not inclined like this but like this, right? So I put it here. Now this is at an angle 90 degrees with the field. So in that case, because theta is 90, my sine 90 is equal to 1. Hence, the torque acting would be P into E. This is the maximum torque acting on a dipole. Thus, we can say that when an electric dipole is placed, so when it is placed in an electric field perpendicular to it, it experiences a maximum torque. So this is the special case that when an electric dipole is placed at 90 degrees to the electric field, then it will experience a maximum torque. I hope you understood the concept of torque acting on a dipole when it is placed in an external electric field.
Please follow us on Instagram, Facebook and Twitter at tribetopper.com.